Yeah, yeah. I have to turn on some because I don't know. I can't see well as. Yeah. Yeah. Thank you. Oh, if you forgot your glasses, feel free to move up. You're okay now? Okay, I'll try to make it closer. Is that better? Okay. So let's take a look at example number 3. This one, as you can see, no graphs given at all. What we're going to do is we're going to just look at the information in here and find out what the non-permissible values are, the NPV, the vertical and horizontal asymptotes. And can you see the word equation? It has to be an equation. Okay, so there has to be like x equals or y equals. And then the coordinates of any whole. Okay, those are the things that we're going to do. So in this particular case, what do we have to do first? We have to factor it out, right? So it's going to be, what's a factored form of the numerator? X plus 5, x minus 5. Very good. Okay? And the denominator is going to be x plus 5. Good. Okay? So, the very first thing is the non-permissible value or value. So what's a non-permissible value in this case? So yeah, we look at the denominator to figure out the non-permissible value. So it's going to be x plus 5 because this can't be 0. So x is equals to negative 5. Okay, good. Now, what about equations of any vertical and horizontal asymptote? The non-permissible value is the one that's going to give us either the whole or the vertical asymptote. Now, what about this one? Hey, these cancels. X plus 5 is a common factor. So that means x minus 5 is a whole. So this is going to be a whole. This is the x value for the whole. Okay? So if this is a whole, is there any vertical asymptote? Okay? So this, we already said this is a non-permissible value, and that non-permissible value is a whole. So that means no vertical asymptote. Or we can say none, right? None. Okay. Now, what about horizontal asymptote? How do we figure out the horizontal asymptote?
In other words, if we have 4, we don't have the asymptote.
Yeah, because there's only one in here. Yeah, there's only one factor, and that factor got canceled. So yeah, in this case, just the whole. Yeah. Okay. So any horizontal asymptote, we said that if the degree of the numerator is that one, right? It's going to be an oblique, and then we perform a division. So if you divide, that cancels. So horizontal asymptote is none, but there's an oblique line. There's going to be an oblique line. Just an oblique line. Okay. So there's an oblique line at x minus 5. Okay, because if we take this divided by that, our answer would be y equals to x minus 5. Okay. So now what's the coordinate of the whole?
Before that, let me ask you, if we have the whole, does it mean we always don't have vertical asymptote?
No, not necessarily. So the question is, if there's a hole, does that mean no vertical asymptote? I'll show you an example. If we look at this one here, this one has a hole and also has a vertical asymptote. So that's if we have two factors. If we have two factors, if one cancels, then that's going to give you the hole, and the one that doesn't cancel, that's your vertical asymptote. Is that okay? Did I answer your question? Yeah.
The one we cancel cannot be vertical.
Yeah, the one that we cancel cannot be vertical. Nicely said. Okay. Now, any other questions?
So oblique you mean linear, right?
Linear, yeah. We're going to end up with a linear function, right? Because that cancels out the linear function. Oblique line. So anyways, coordinate of the hole. Where's the hole? We know the hole is going to happen if x is equals to -5. Now, if x is -5, what is the y? So y is equals to, okay, we've already canceled the x plus 5. We have just the x minus 5. We're going to put -5 over there. So y is equals to -5 minus 5. So y is equals to -10. So therefore, hole is at which one? -5 for the x and -10 for the y. Okay? At this particular point, we're not graphing. We're not graphing right now. We're just figuring out the different characteristics of it. Okay? Is that okay? Yeah, if you have questions, just ask, okay? Because I don't want us to kind of go home and then not getting their questions answered. So is it okay to go to B? To B, yeah? Okay, now what do you see here? First, we're gonna see, okay, we don't have to factor this, it's just 5x plus 3 divided by x minus 2. What's a non-permissible value? X is equals to 2, yes, okay. Now the non-permissible value, that doesn't cancel, right? It's not a common factor. So therefore, what's the vertical asymptote? X equals to +2. Are there any holes?
No.
Okay, no holes. Let's just put that here. No holes or hole. And then horizontal asymptote. How do we figure out the horizontal asymptote? The degree of the numerator is equal to the degree of the denominator. So what do we do?
5 divided by 1.
Y is equals to leading coefficient of the numerator, which is 5, divided by 1. So it's just going to be y equals to 5. Okay. So in this case, there's a vertical asymptote and a horizontal asymptote. Let's just see what that looks like, just for the fun of it. So there's a vertical asymptote at 2. So where's 2? 1, 2. Make sure it's dashed. Right, this is the 2 dashed. X equals to 2. And then the horizontal asymptote is at 5. So 1, 2, 3, 4, 5. Okay, so your graph will be in two of the areas in here. Okay, it's either here and here or here and there. Okay, we'll figure that out. So far so good? Yeah? Let's take a look at letter C. What can we do first? Factor. Yes, we're going to factor the numerator. So y is equals to x squared. Oops, I don't have to rewrite it. The factored form was be x minus 2, x plus 1. Is everybody okay with that one? Yeah? Okay. Yes? X squared would be x times x, negative 2, so it's negative 2 and 1. Okay, so that's, what's a non-permissible value? X equals to minus 1. Okay, now that x, there's a common factor there, so that's the denominator cancels, so that tells us that there's going to be a whole. It'd be a whole. No vertical asymptote. There is a whole at x equals to negative 1. Okay. Well, if x is negative 1, we want the coordinates. So what's the y value for that? So y is equals to x minus 2. So we put in the negative 1 there. So negative 1 minus 2. So y equals to negative 3. Oops, can't see that. Okay, so the coordinate of the whole is at, okay, x is negative 1 and y is negative 3. Okay, now this one here is completely canceled. When we divide it, we're gonna get exactly x minus 2. That's the only line we're gonna be left with. So that's gonna give us just a line y equals to x minus 2, and then there's a whole at negative 1, negative 3. Okay. Yes? Yeah? Good. We're just learning how to get the pieces of the puzzle, and we'll continue on with. No.
So then why isn't the x minus 5 with the asymptote
For A?
Yeah. Or is it just...
Oh, no, there is no oblique asymptote.
Oh,
Yeah, just a line. Okay. just a line. Yeah, is that okay? Yeah, okay. I was like, oh, okay. Good. Now you're wondering, it's like, okay, so when do we get an oblique one? Huh. Oblique one happens when there's a remainder. Remainder after you've divided it. So let's see this one here. You know, I was talking to one of my colleagues there. His name is Hip. You probably had him before. He teaches calculus at school, only in semester 2. So if you're, maybe next year, if you want to take a calculus here, but maybe not, because you're already going to be. But he does calculus, and we had a conversation, and he says, you know, it's very rare that we do limits on oblique. It's either vertical or horizontal. And is that true in your case, or do you see? Yeah, most of the time it's just vertical or horizontal part. So he mentioned that, and it's like, okay, because teachers talk about stuff, the math. So that's what he said. Okay, let's get on with this one. Okay, why don't you go ahead and factor the numerator? I'll do the same. So go ahead and factor the numerator. Did you get x? Oh yeah, you might have reversed these two, right? If you start with the +7 and then -1 after. Okay, good. So, what's a non-permissible value? Non-permissible value is -2. We'll make the denominator 0, so -2. Okay. Okay, so that non-permissible value is not doesn't cancel, so that means vertical asymptote is x equals 2 minus 2. Any whole? No whole. No whole, because there's no common factor between the numerator and denominator. Okay, so what do we do? What do we do? What about horizontal asymptote? And this is where we're going to see the horizontal asymptote. So nothing cancels. What are we going to do? The degree of the numerator is greater than the degree of the denominator. I'll write it down, so just in case people are wondering what we're talking about. Is greater than the degree of denominator, q of x. Then we're going to end up with a horizontal, with the oblique asymptote. We have to perform a division in here. Oh, okay, we know how to do that. So how do we do that? You remember the dividing? It's 1, 6, -7. And what are we going to divide it by? It's a -2. Okay. So bring down the 1. 1 times -2 is -2. 6 minus 2 is 4. 4 times -2 is -8. And then add that would be -15. Okay. So that tells us that it's really approaching the x plus 4 line, but because we have this remainder, the remainder is -15 over x plus 2, right? So it's going to be, and what's happening here is it's really approaching this line. As x gets bigger and bigger and bigger, it gets closer and closer to this line. Is that okay? If we keep increasing the x, it's gonna approach this line. So there's an oblique line, oblique asymptote. Oblique asymptote at y equals to x plus 4. Okay. This one here, the reason why it's an oblique asymptote is because of the remaining part in here. As this x increases, the value gets closer and closer to x plus 4. Okay. So that one has a vertical asymptote. Let's see what that looks like. I don't have room. I'll just try to squeeze it in here. Vertical asymptote at -2. And then there's an oblique asymptote. Remember, like when we divided these two, it didn't go exactly as x plus 4. There's a remainder. So that's the one when we have an oblique. So it's going to be x plus 4, 2, 3, 4. That's the y-intercept. And then the slope of 1. So this is your oblique line. Oops. Okay. So right now we're stopping there, figuring out where the oblique is, and no holes. You okay? So far so good. We're taking our time to really explain this, not rushing it. Okay, next one. Any thoughts? What are you gonna do? What are you gonna do first if this is a question? Factor, right? Is it factorable? Yeah, y is equals to, it's exactly the same thing as that. Oh, it's exactly the same thing, but it's kind of reversed, right? Yeah, okay, let's see. Do you think it's going to be exactly the same? If you flipped it? If you reciprocated it? Do you think we're going to have the same characteristics? No. So y is equals to x plus 2 over x plus 7, x minus 1. The non-permissible is what? Excellent. Yeah, very good. -7 and very good. Very good. Any question about that? No. Anything cancels? No, nothing cancels. No common factor. So that means there is no hole. No hole because there's no common factor. Okay? Between the numerator and denominator. Okay, good. So what's a vertical asymptote? 1 and -7. Yeah. Vertical equation of the vertical asymptote would be x equals to -7 and x equals to 1. Okay. What about any horizontal asymptote? Okay. The degree of the numerator is less than the degree of the numerator. So that means the denominator gets bigger and bigger and bigger. This is my cookie, right? You're going to have to divide by a large number, so it's going to be y equals to 0. Okay, so y equals to 0. Okay, what does that look like? Oh, this is a very typical question. Vertical asymptote at -7. 1, 2, 3, 4, 5, 6, 7. And then a vertical asymptote at 1, 1. And then horizontal asymptote at 0. So that's I know it's like right on the x-axis, so we have to really show it. Okay, so like kind of do the dash, because asymptote is a dash. Yes, so far so good. Yeah. Okay, good. Last one. Last one. Anyone writing? You're good? You're done writing? Yeah? Okay, let's do the last one. Oh, this one. What's happening with this one? Oh, nothing to factor, so that's great. Start with the non-permissible value. What's a non-permissible value? Non-permissible value is x equals to -3. Okay, anything cancels? Nothing, right? So that gives us a vertical asymptote. Vertical asymptote at -3. Horizontal asymptote. Oh, we'll just put no whole because there's no common factor. And horizontal asymptote is where? Or is there any? Yeah, so the degree of p of x is less than the degree of q of x. So that really approaches y equals 0. Okay, so y equals 0. So what does that look like? Again, a very typical type of question. Vertical asymptote at -3. And then the horizontal asymptote at 0. I'm gonna make this really obvious. An asymptote is a line, right? So make sure you put an arrowhead on each end. Okay. Otherwise, it's gonna be some kind of a technical communication error. Okay. And then there's your graph. Good? Yeah. Awesome. So, today we really spent time on gathering all the pieces in our puzzle. The pieces of our puzzle are non-permissible value, vertical asymptote or whole, a horizontal asymptote or oblique. I think we're ready to graph. Let's see if we can graph today. Okay. So just to let you know, when we're graphing, I'm not going to finish lesson 5. It's not possible to finish lesson 5 today, but we will talk about the first example. Okay? So we are sketching a graph. Sketch the graph of this function. Okay. So the very first thing that we got to do is to factor them. Okay, so go ahead and factor this trinomial. X minus 3, x plus 2, yes? Yeah, good. Any thoughts? Now that we have it there, what do you know? It's like gathering your puzzle piece. We're gonna, non-permissible value is -2, so x is equals to -2. Yeah. The x plus 2 cancels, right? Okay, so now if we take the numerator and we divide it in the denominator, we're going to have exactly an x minus 3 equation. So there's a whole. Okay, I'm going to start there. So there's going to be a hole at x equals to -2. So if x is -2, where's the y? Y is equals to x minus 3. So we've already canceled this out. This is gone, so it's going to be x minus 3. And then we're going to put the -2 in here. So y equals to -2. Oh, you guys are so fast. I'm so slow. I'm a slow writer and a slow thinker. Okay? That's okay. Slow doesn't mean it's a bad thing. Okay, so where's the hole? Hole is at -2, comma, -5. Now this is a coordinate point, so we have to make sure we put it inside the brackets. Okay, so hole is there. Now what about horizontal asymptote? Horizontal asymptote, the degree of numerator, p of x, is greater than the degree of the denominator, which is a q of x, by 1. So if we divide those two, what are we going to end up with? If we divide it, we're going to end up with exactly y equals to x minus 3. Is that okay? Do you want me to show you that one? No? Okay, because we already know that they cancel out, so the only thing that's left is x minus 3. No remainder. It's exactly x minus 3. Exactly. No remainder. So in this case, we're going to end up with the exact oblique line, okay, with a hole, okay. So oblique line of x minus 3. How do we graph y equals to x minus 3? Minus 3 is your y-intercept. This is like the grade 10 topic. And then the slope is 1. So that means from the y-intercept you go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. I'm going to use my ruler to draw my line, straight line. Okay. So that's okay. So that's, I would end up with a straight line, but where's the hole again? The hole is at -2, -5. So where's -2, -5? -2, -5. So there's a hole here. Okay. So far, so good.
Shouldn't you draw the hole first and then put the line over?
You could, yeah. You could do that. Yeah, certainly put the hole in it. Or, yeah. Your preference. Okay. Let's see if we did everything. We did the non-permissible value, check. Holes and vertical asymptotes. Horizontal asymptote, if you get one. What about the intercept?
Hello all students, the University of Manitoba's Access Program will be presenting in the student lounge at 1 p.m. So come on down.
Now the only thing that we didn't do is the x-intercept and y-intercept, okay? We actually can see the x-intercept and y-intercept from here, but then how do you calculate it without this one, right? How do you algebraically calculate the x-intercept? Yeah. To calculate the y-intercept, what do we need to do? We set x equals to 0. Okay, so set x equals 0. So y equals to 0 squared minus 0 minus 6 over 0 minus 2. So y is equals to 0, okay, minus 6 over minus. What did I do? Yeah, it's plus 2. Yes, plus 2. Thank you. I was like thinking, uh-oh, it's not matching. Negative 6 divided by plus 2, it's negative 3. And does it look like it's a negative 3 there? Yeah, it is. Yeah. Okay. So that's a y-intercept. Okay, now on this side, how do you calculate the x-intercept? If we want to have the x-intercept, we're going to set y equals to 0. Set y equals to 0. So y is equal to 0 equals to x squared minus x minus 6 divided by x plus 2. So how do we do that? So we cross multiply that. That becomes cross multiply. So that's 0 equals to x squared minus x minus 6. You factor that out. It's going to be x plus 1, x plus 2, x minus 3. So we have, looks like we have two possibilities. Okay, let's see here. X equals to negative 2, x equals to minus plus 3. Okay. Okay, so then you go here. Oh, x minus 2. Hey, that's my non-permissible value. So this can't be the x-intercept. The x-intercept has to be this one. This non-permissible value. So this has to be the x-intercept. So if you look at our graph, here's our x-intercept at 3. So algebra, our calculation, matches what we have in our picture. Okay, they have to go hand in hand. Like we can't calculate one thing and then the graph a different thing. So it doesn't make sense. So they have to agree with each other. So I'm gonna stop right here, give you a little bit of a break. If you are still working on that hand-in assignment, you can give it to me sometime today up to 3:30, and then if you need extra time. Other than that, have a good afternoon, and I will see you tomorrow. We'll finish this up tomorrow. Okay?